Okay, students, in this video, we are going to talk about reflection. Okay, for this particular chapter, there are a lot of common terms that we'll be using throughout the whole lesson itself. So it's important that you get familiar with those terms first before you move on. First term that we're going to talk about is this term called normal. Okay, normal is a imaginary line that is perpendicular to the surface. Okay, so a normal is just an imaginary line that is perpendicular to the surface. Okay, next we have this thing called the angle of incidence and the angle of reflection. Okay, so when we talk about reflection, okay, it's important to note that the light ray will be reflected off the surface. So this is something that we are very familiar with because we know that the light rays actually comes in when it comes into the surface. Okay, when the light ray comes into the surface, okay, it gets reflected off the surface. So, like what I've drawn here, I've drawn the normal. Okay, remember, like what I mentioned just now, the normal is actually an imaginary line that is perpendicular to the surface. Okay, so this light ray that comes and hit the mirror surface that I've drawn here, okay, this light ray is what I call the incident ray. Okay, the light ray that is coming in to incident onto the mirror surface. So what is this angle of incidence? Well, the angle of incidence is defined as the angle that is between the normal and the incident ray. On the other hand, the angle of reflection is just defined as the angle that is in between the normal and the reflected ray. Okay, so you realize that we have now quite a number of terms to work with, okay, and we are going to make full use of these terms as we go along the rest of the video. Okay, so now that we've talked about angle of incidence, incident ray, reflected ray, the normal, okay, it's important to note there are some laws of reflection that light always obeys. Okay, so in the law of reflection, in the law of reflection, there are two parts. First part is that the angle of incidence is always equals to the angle of reflection. Okay, so this one is very simple, like what I've drawn here. Basically, we are just saying that this angle between the normal and the incident ray, if let's say is 20 degrees, then the angle of reflection here will also be 20 degrees. Okay, so this is the first law of reflection. There's a second part to it. Okay, for the second part, it actually says that the incident ray, normal, and reflected ray lies on the same plane. Okay, for those who are not familiar with this word plane, it's actually a mathematical term that says that they are all on the same surface. Okay, let me give you an example, okay, using this diagram again. Okay, if the light ray, okay, is on the surface of this paper and is heading towards the mirror, which is standing up like this, okay, and it gets reflected off the mirror like this, okay, we'll say that the incident ray, the normal, and the reflected ray are on this same surface and hence they are on the same plane. Okay, so this is something that really happens in real life, and we know that in real life, the mirror doesn't allow the light to actually bend towards you. Okay, like this, when the incident ray is on this surface of the paper, hits the surface of mirror here and gets reflected off in this way towards the camera here. So if that doesn't happen and the light ray continues to travel on this same surface of the paper, then we are trying to say that the incident ray, the normal and the reflected ray all lie on the same plane. Okay, so there's two laws of reflection for you to remember. Okay, but it's also important to note that this is not the end. It might seem very easy, okay, but majority of the reflection actually revolves around the drawing and identifying of the images and ray diagrams. Okay, so here is a particular page that you might want to take note of. Okay, for this particular page, okay, I have summarized the steps for drawing the ray diagrams for reflection. Firstly, measure the distance between the object and the mirror, after which you duplicate this distance on the other side of the mirror and mark the image of the object. Thirdly, you draw the rays from the object leading to the mirror and then draw the reflected ray to the observer. Now it might seem very abstract. Let me use an example to show you. Over here, I've drawn a mirror, an object, and an observer. Okay, so let's follow step by step what I've mentioned just now. Okay, take note that down here you see the slash here, the slash. Okay, the slashes here represent the inside of the mirror, while the side without the slash actually represents the mirror surface itself. Okay, so let's start. Okay, so using the first step, okay, I'll measure the distance between the object and the mirror. Okay, and I'll duplicate it on the other side on the second step. So I'll take a ruler, I'll measure, okay, from the object to the mirror, which happens to be 2.5 here. Okay, usually I'll also ask everyone to draw the dotted line through as well. Okay, because we need to make sure that this is 90 degrees so that it is on the same straight line. Okay, I'll duplicate it over on the other side. 2.5 times 2 is 2.5 here. So on the other side, I must duplicate 2.5 as well. So it will mean that I am at 5 cm here. Okay, so once I mark out the image, this position, 5 cm is actually our image. Okay, so how do I do step number 3 now? Okay, step number 3 is done in a reverse manner. Okay, let's look at how I do, okay? First, okay, you notice that I draw the eye of the observer here. Okay, so I am going to draw 2 rays, okay, from the image to the observer first. Anything that is within the mirror, I'm using dotted lines to represent it. Anything that's outside the mirror, I'm using solid lines to represent the light ray. Why is there a difference? Because within the mirror itself, the light rays doesn't exist. On the other hand, when it's outside here, the light rays do exist, and it is the reflected ray. So let's start. Okay, so from the image itself, okay, I'm going to draw a light ray that is reflected off the mirror to the top of the eye. So look at what I'm doing. Dotted line all the way to the surface of mirror, after which I will transit into a solid line itself. I repeat the same for the bottom of the eye here. Dotted line, after which I'll transit into a solid line. Okay, so you see that there is 2 lines branching out from 2 different parts of the mirror. Okay, that's because we are trying to tell people that there are two light rays that actually came out from the object, gets reflected at the mirror at these two positions to the observer, but to the observer the light rays actually so-called coincide together and form this image itself. So let's complete this ray diagram. 1, 2. Okay, it's also important to note that this is actually not the standard way of drawing, but it's a simplified way to make sure that we get the image drawn at the correct position. Okay, so this is how we are going to draw the ray diagrams for reflection. Now let's look at this ray diagram very carefully. Oops, sorry. Let's look at the ray diagrams this ray diagram very carefully. Okay, and we'll discuss the characteristics of the image of a reflection. Okay, why do we need to do that? Because we know that when we look into a mirror, okay, there are some characteristics of the image. Okay, so let's start with what we can see from the ray diagram here. Okay, firstly, the image is inside the mirror itself, right? Okay, when it's inside the mirror, there is no way that we can project it onto the screen. So we say that the image is virtual. Okay, next, notice that I mentioned at the start, okay, that when we measure the distance of the object to the mirror, we will duplicate it on the other side, because we are actually using the second characteristic of the image for reflection, which is the distance between the object and the mirror is the same as the distance between the image and the mirror. Okay, this is a very important point, because knowing how far the object is from the mirror, we can actually predict how far the image will be. And many opticians actually make full use of this property to shorten the length at which their items need to be placed, okay, so that we can still get the same distance out of it. Okay, so later we'll talk about some examples, or we'll discuss some examples on how this property is actually being used. Okay, thirdly, this image, okay, is the same size as the object. Okay, trust me, it is the same size. Okay, if you don't believe me, you can look into a mirror. Okay, if your eye is 1 cm wide, the image itself that you see of your eye is also 1 cm wide. Okay, and fourthly, okay, image is laterally inverted. Okay, it's important to note that for this fourth characteristics is actually a perception. Okay, what do I mean by laterally inverted? Okay, when you look into the mirror, okay, so position, if you have a mirror in front of you now, look into the mirror. Okay, raise up your right hand, and you notice that the image of yourself in the mirror actually raises its left hand. So this is what we mean by laterally inverted. Okay, so I hope you have understood what we have mentioned so far. Okay, let's move on to the next portion, okay, which is me giving you an example, okay, of how a question for reflection can be used. Okay, but before that, okay, can I come back to this part? Okay, down here when we talk about the characteristics of image for reflection, we are actually talking about plane mirror. Okay, for plane mirrors. Okay, plane mirrors just mean mirrors that are flat. Okay, it's not warped in any way. Okay, so it's actually the mirror that we usually use to look at ourselves in the bathroom. Okay, so let me give you an example, okay, of how the second characteristic, which is the distance between the object and mirror, is the same as the distance between the image and the mirror is being used. Okay, so let's talk about you being in a room where you're positioned in this way. Okay, let's say down here is the object. Okay, you are actually positioned here, and the mirror is here. Okay, so you will be looking towards the mirror. Okay, while on the other hand, the object is actually placed behind you. Okay, so this is actually what is happening in the at the optician. Okay, you're actually looking towards the mirror. Okay, and the image and the chart that is used to test for your eyesight is actually behind you. Okay, so I'll give you some more details here. Let's say that the distance between the chart or the object in this case is 5 meters. Okay, and the distance between yourself and the mirror is maybe 3 meters. Okay, so question: how far is the image of the object from the observer? Okay, observer being the person here. Okay, so if you look at this question itself, okay, the object is actually placed behind the person, but the object is 5 meters away from mirror. Okay, next we also know that the mirror is 3 meters in front of the observer as well. So if you look at this question, the question is actually asking you how far is the image going to be. Okay, image is definitely going to be somewhere behind the mirror here. How far is it going to be with respect to the observer? Okay, so looking at the second property of the characteristics of the image for reflection for plane mirrors, okay, we know that the distance between the object and the mirror is the same as the distance between the image and the mirror. So looking back at this question, I can safely say that the object, okay, which is here 5 meters away from mirror, will create an image. Okay, will create an image. Let me use dotted lines to represent it. Okay, we'll create an image that is also 5 meters away from the mirror. Okay, but it's behind and it's virtual. You cannot touch it. You cannot project it onto the screen. So now that we have applied the second characteristic, let's look back at the question. Okay, so we know that the image is now 5 meters behind the mirror. The person is 3 meters in front of the mirror. So total distance between the person, the observer, and the image is actually 5 plus 3 meters. Okay, so the question, now we are going to answer the question, how far is the image of the object from the observer? Okay, distance. Okay, here is the answer, okay? Distance between the image and observer equals to 5 meters plus 3 meters, which is 5, 6, and 8 meters. Okay, so now the person, the observer, actually sees the image 8 meters away from himself or herself. Okay, and this is how the doctors, okay, who are checking your eyesight usually plays around with the distances, because there's just simply not enough space to really create 10 meters worth or 8 meters worth of space in front of you. Okay, so at this point, I hope that you have understood, okay, what we have gone through for the chapter of reflection. Okay, I'll create another video on the chapter of refraction, and hopefully through all these videos you can understand what we are looking for in the upcoming lessons ahead. Okay, thank you.